Hello everybody, my name is Dyllan Usher and today we're going to be discussing the unsupervised analysis of climate zones in West Africa. My name is Dyllan Usher, I'm a recent Metis Data Science Bootcamp graduate, and Metis is an intensive 12-week data science immersion course focused on teaching the fundamentals of data science applied in the workplace. If you would like to learn a little bit more about me, feel free to visit the links in the description below, and if you would like a more detailed explanation of this project, I'll also link that below. This project focused around Bootcamp Gona. It's a farming service supported by the Peace Corps focused on helping smallholder farms in Nigeria. And over the past 8 years, they've reached out to over 65,000 farmers and increased their productivity and profitability. By 2025, however, they want to reach out to 1 million farmers. And with limited resources, how should they focus their efforts? One factor that we need to consider is which areas are most impacted by climate change. For this project, I used the ERA5 monthly average data set from the 1979 to present, and it was at a 0.5 degree spatial resolution, so I could look at regional climate change. And I used the 2-meter temperature and total precipitation values respectively. So first, I engineered features based off of the Koppen climate system, which is a standard system for assigning zone membership. And after a proof of concept by clustering on global Koppen features, I clustered on the regional features of West Africa, and then analyzed the cluster movement by mapping the percentage change of these features. And finally, I developed a plan of action as to where to allocate Bootcamp Gona's resources. So one of the fundamental flaws of the Koppen climate system on the left is that it makes arbitrary rules to decide climate zone membership. The crux of my project is to let the data speak for itself using unsupervised techniques. If we increase the number of clusters to 31, matching the number of regions defined by the Koppen system, we can start to see that a lot of the subtleties that are picked up by the Koppen system are also picked up by the k-means clustering. So after proving to myself that clustering climate data is a reasonable approach, I clustered on the West Africa region. On the left, you can see clusters formed from the 1980s, and on the right, the 2010s. The key idea here was to cluster on both space and time to allow meaningful cluster labels across time. If we count up the number of cluster labels, we can get a map of the relative size of each cluster for the West African region. Movement along each of the cluster total lines shows definite signs of cluster movement, but we still don't really know what each cluster represents. By calculating the max summer temperature percentage change from each cluster from the 2000s to the 2010s, we can see a definite sign of extreme heat events in the northern and southern regions of Nigeria. Once again, if you would like more details, please visit the in-depth presentation below. But if we zoom in, we can see a high level of extreme heat events in Region 1, a medium level in Region 2, and a low level of extreme heat events in Region 3. By doing the same sort of analysis to the max summer total precipitation percentage change from the 2000s to 2010s, we can observe Regions 1 and 2 showing a 30% decrease in precipitation, and Region 3 showing a 10% decrease in precipitation. Now, with these regions of unique climate change in mind, I recommend first focusing on Region 1, marked with signs of drought and a 15% increase in maximum temperature. This region is also home to the largest population densities in Nigeria, making food scarcity a top issue. Furthermore, the headquarters of Bootcamp Gona farmers is located along the southwestern coast in Lagos, making this region the first logical step towards helping smallholder farms. The regions labeled 2 mark a 30% decrease in max precipitation and a 10% increase in max temperature. Thus, this area has a severe risk of drought and a high possibility of decreased agricultural yields due to extreme change in climate. However, they aren't as populous, making them priority number 2. The third region marks a 25% increase in max temperature and is also the second most populated region of the regions highlighted, making food scarcity from sun scorching a real threat, especially to non-root vegetables, which are more sensitive to heat. However, as of recent, this area hasn't seen a significant decrease in precipitation, making it the lowest priority region as of yet. However, with the changing climate, we might still find this area to be drought prone in the future. And with that, thank you so much for your time. I hope you enjoyed my presentation, and I would like to thank Metis Data Science Bootcamp for giving me the foundation I needed to continue my data science journey. If you have any questions, feel free to either email me or leave a comment below. Take care.